I'll just give a quick overview of what
Yes, there we go, Bob.
what the demo is about, though. So you see a live simulation here of a vRAN network, which is modeled on the cRAN architecture, which means the VDUs are at a centralized RAN location. You see cluster of sites. You have 4 clusters, 2 clusters with 3 sites each, which are the vRAN, and 2 clusters with 2 sites each. They serve their coverage areas. And what this demo shows is some aspects or taps into the benefits of vRAN. So some of those are like, how can you achieve load balancing across this entire network? How can you be better prepared to address some of the dynamic changing conditions in the network? How can you, so let's look at each one of them. So here you will see certain notifications of how your conditions in the network change dynamically. So insufficient capacity detected, okay? So it tells you exactly how you can, change the load balancing dynamically in the network and be better prepared to achieve that. And sometimes, you may need to add a different node. So once you hit submit,
What were you changing in that 0 to 300?
so those are the resources that site can handle. Yeah. So for example, if this cluster is going to get more traffic on it, then we can plan and dynamically change the resource allocation. So that can be done in a few ways. You can add a virtual distributed unit. So that is going to be a quick scaling. You tap into the scaling, scale out features, and you can automate that. You can orchestrate and add a VDU. And the second benefit is the power consumption, because when you look at the traditional RAN, the CPU utilization is always high, but with this VDU you can do an ad hoc. You can have certain CPUs be sleeping, not consuming that much power. You can enable accelerators, which also does very fast processing. The 4G and 5G processing power is fast, and during the cell setup, you only assign the amount of CPUs you want. You don't want to assign more than what is needed. So that power consumption is also a key factor. And then, for example, you look at this, you have a public event that is being supported by the sites I and J, and this public event is maybe a concert that is scheduled. So you can select the right network slice, optimize for entertainment, and then add to timeline. So as and when that event occurs, you're already planning for addressing that event for a network slice which would be critical for entertainment, and you will be able to basically make all those changes in advance. So right now the public event is ongoing on those clusters.
So you have to be provisioned for that peak capacity.
Yes.
You are
Yes,
basically
have to be
unlocking the
provisioned.
capacity.
So this basically, so now look at this power consumption. The accelerator cards, if you enable them, they're going to you can add more videos, but at the same time not incur more power consumption. Those videos that you add are being offsetted by the accelerator cards, which is going to help further save power. So you're tapping into the power consumption benefits, and the power consumption benefits are many, like the CPU sleep cycles, the energy saving features on the orchestrator itself. So the vRAN 3.0 solution taps into a whole bunch of potential.